So this is the third page of Unit B investigation, where we're dealing with 30-degree reference angles. So let's do what it says in step 5, which is to find all the points for the triangles with 30-degree reference angles. So we have a 30 degrees right here, 150 degrees right here, 210 degrees, and 330 degrees. So those are all the points with 30-degree reference angles. Now the key is that we need to form a right triangle with each of these angles. So why don't we go ahead also before we do that and just label the angles 30 degrees and pi over 6. And here we have 150 degrees and 5 pi over 6. Here we have 210 degrees and 7 pi over 6. And lastly, we have 330 degrees. And you can also think of that as 11 pi over 6. And maybe I'll use a slash just to show you that we're not dealing with points right here. We're actually dealing with angle measures. So we actually want to find the coordinates of each one of these points. Now the key thing here is we're dealing with the unit circle. So any radius of the circle measures 1. So anytime we draw a triangle, the hypotenuse's length is 1, and we need to find the x value for that triangle and the y value. And in fact, they're all going to be the same because they all have the same reference angle. Okay, and so for this first one right here, let's draw that triangle in. We know that it was a 30-degree rotation, so we have a 30-degree reference angle. And we know for 30 degrees, if the hypotenuse's length is 1, the shortest leg opposite 30 is 1/2, and then the middle length side is going to be rad 3 over 2. Okay, and so that helps us define the x and y coordinate because we essentially did what? We went over rad 3 over 2, so we went to the right rad 3 over 2, and we went up 1/2 to get to this point. So the coordinates of this point right here are rad 3 over 2, comma 1/2. Well, let's take a look at the second quadrant. We're going to do the same thing. We're going to create a right triangle. We know the hypotenuse's length is 1. We can draw the rest of the right triangle in right here. And we know that the reference angle is 30 degrees. Well, opposite side of the 30-degree angle when the hypotenuse measures 1 is 1/2 of 1, which is 1/2. And the side opposite 60 is rad 3 over 2. So similarly, this time though, we're in the second quadrant. So we went to the left. So that's negative rad 3 over 2. And we went up 1/2. So that's a positive 1/2. So when we go ahead and write these coordinates, again, we said we went to the left rad 3 over 2. So that's negative rad 3 over 2. And we went up 1/2. So that's a positive 1/2. That's the coordinates of this point. Let's go to the next one. Now, you can see that it looks like we're going to have a similar situation here. So if we look at this triangle, that's going to be the same as all the other triangles that we've looked at so far in this case. So what that means is we're going to have a similar conclusion with the coordinates. If we label the sides here, we go left rad 3 over 2, so negative rad 3 over 2, and then we go down 1/2, so negative 1/2, since again we have a 30-degree reference angle for 210 degrees. Well, the coordinates of this point then are, we went left rad 3 over 2, this distance, and we went down 1/2 this distance. So negative 1/2. And again, the coordinates are the same, except they might either be positive or negative depending on what quadrants we looked at. Okay. And lastly, we have this point right here, which is 330 degrees and 11 pi over 6 in radians. Again, we have this triangle right here whose hypotenuse's length is 1. The hypotenuse of that triangle is 1 right there. Sorry for the messy hypotenuse right there. And again, we go rad 3 over 2 to the right, and we're going to go down 1/2 units. So that gives us the coordinates of this point as positive rad 3 over 2, our x value, and negative 1/2, our y value. Okay, and so we have essentially the coordinates for all 30-degree reference angles.